Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to IGNova. New video today for 06 to 5, February, March 2025. According to updated syllabus for physics paper, let's start. Question 1. The diagram shows three forces acting on an object. Here we have three forces, 1, 6, and 9. What is the magnitude of resultant force acting on an object? To calculate the magnitude or the resultant force, we have here, see, this one will be cancelled from 1 here, so 9 minus 1, so for the right side, it's 8 Newton. For the vertical side, here is 6 and nothing opposite. So it's 6 here, the resultant force. This is a hypotenuse. Which rule going to be used? Pythagoras theorem. 6 squared plus 8 squared. They will be 10 Newton. So the right option is B. Question 2. Which row defines the speed and velocity? Here, as the distance traveled in a given direction, no speed, it's not in a given direction. So, given direction is not. Distance traveled per unit time, yeah, this is the speed. So, correct options may be B or D. For velocity, it's a speed, yeah, in a given direction, surely, yeah. So, right option is B. For D, here, speed per unit time, this is the acceleration. So, correct option is B. Easy. Question 3. The graph shows the journey of a motorcyclist. Which section of the graph shows the time when the motorcyclist is stationary at some traffic light? At some traffic light means speed here must be 0. Doesn't move, stationary. So which one described that? It's surely it's C. Easy. Question 4. The acceleration of a free-falling moon has 1/6 of its value on Earth. Here, g of moon equal to 1/6 g, 1/6 g of Earth. On Earth, the astronaut mass is measured as 60 kg. Here is the mass. Which row gives the mass and weight of the astronaut on Earth and on the moon? For the mass, as it's 60, it doesn't change on Earth, on moon, on any other planet. So mass is constant. I'm gonna go for mass here as a constant. It's 60, yeah, and 60 here. So maybe option B or D. For the weight, see, weight, it's M times G. And we know that mass is 60 and G is 9.8 on Earth. So 60 times 9.8. The answer is 588. 588 by rounding, it's 590 here. So correct option is D. If you use 98 here, you're gonna find it 1/6 of 590. Good question. Question 5. The load extension graph for material is shown here, which point indicates the limit of proportionality. Before limit of proportionality, according to Hooke's law, K equal F over delta X. K is a constant and Hooke's constant. F is a force and delta X is a change of expansion happen. For that, it's a direct relation described by straight line. After limit of proportionality, the expanding line is this expanding line will not be straight, it will change. So this is the limit of proportionality described by point A here, straight line, and after that it's a random deformation, distortion happen. Good question. Question 6. An object of mass 4 kg. Here is the mass moving with a velocity 3. Here is the velocity in a straight line. What is the momentum? Momentum, it's a PL equal mv. M is 4, V is 3, gonna be 12. Unit is kilogram for mass, and for V, meter per second. So it's a 12 here, option C. Easy. Question 7. A tall cylinder is partially filled with two liquids. Here, liquid 1, liquid 2, which don't mix. Okay, so separated surfaces here. The two liquids have different densities. A student measures the pressure due to the liquids at a different depths. Okay, what happens to the pressure through liquids? You know that if you remember the rule, P equal rho G H. Rho, it's a density, G gravity acceleration, H is a depth. For that, which graph shows how liquid's pressure varies between P and Q? So this graph, I'll apply 4 graphs on this. For this graph, graph A, here at point P, this is the first one, here is the first one. Okay, it starts to increase, yeah, because density increases till point, this point described by separated surface, and then density, the pressure to depth, which is density, increases. But here, which one increased more? More slope means more density varies. Which one the density varies more? The upper or lower? Surely it's lower one. For that, this graph, if you describe the graph for the second liquid, it will be more slope. Compared this point to this point for graph B, you're gonna see that increasing in depth is more here than a first liquid, which is the actual description for varying of pressure here. For that, the correct graph is B. C or D cannot be because here at a constant while density varies, so he told you here different densities cannot be C, and here it's constant pressure while depths happening, and this is wrong. So the correct option is B. The difference between B and A. A, this line describe the increasing in density in the first liquid is more than a second liquid. While it's not actual happen, this one is less than a second liquid. Correct option is B. Question 8.
A tennis ball with momentum 2.3 kilogram meter per second is struck by a tennis racket. Here, tennis ball hitting a tennis racket with a kinetic momentum equal to 2.3. Is struck by a tennis racket, the racket causes the direction of the motion of the ball to reverse. Okay, the racket exerts an average force of 1,500 Newton during the impact. So here is the applied force 1,500. The racket and the ball are in contact with each other for time 0.0024. So time 0.0024 seconds. What is the magnitude of momentum of the ball as it leaves the tennis racket? Okay, if you remember the rule for force, I know that it's a mass times acceleration. This is the first rule. And the second rule, second definition, we define force as the kinetic momentum change, is the change in kinetic momentum during a time interval. For that, the kinetic momentum here, it's force times time. Force is 1,500, time is 0.0024. Let's find the kinetic momentum. 1,500 times 0.0024. Answer will be 3.6. Great. 3.6 kilogram meter per second. While the kinetic momentum of the ball that leaves is 3.6 and there is 2.3 in the opposite direction. So the resultant in kinetic momentum, the required, is the 3.6 in the reverse direction minus 2.3, as this will consume 2.3 will be consumed from 3.6. For that, 3.6 minus 2.3, it's 1.3 kilogram meter per second, which is option A. Easy. Just you need to be careful of the idea of reversing the force. Reversing force, it reverses also the kinetic momentum here. Let's continue.
Question 9. A car is traveling at a speed of 8 meters per second. So this is the V1. The kinetic energy stored in the car is 32,000 joules. This is the kinetic energy 1 in the first situation. What is the kinetic energy stored in the car when its speed increased to 16 meters per second? We need you here to find the kinetic energy stored, kinetic energy in the second situation when speed changes. So how we solve a problem like that? By using vectors. How? See here. From relation KE equal half mv squared, half is constant, mass is constant, so in a direct relation between KE, KE and velocity. For that, in any two situations, I use the ratio method. Ratio method says it's KE 1 over V1 square, don't forget it's a square, equal to KE 2 over V2 square. Substituting numbers, okay, K1 it's 32,000, V1 it's 8 square equal to KE2 that's required, and V2 is 16 square. By using the rule to find KE, cross multiplication, KE2 equal to 32,000 times 16 square over 8 square. Using calculator, it will be 32,000 times 16 over 8 square. The answer will be, 16 square here. The answer will be 128,000. By rounding, it's 130, which is option D. This is one of the methods we can use. The second method I can use, see here. Now, what you're gonna use? I'll use, this is V1, KE1. This is kinetic energy in the second situation, and V2. What you're gonna do? From relation KE equal half mv squared, you can find mass, as a mass will be 2 times the kinetic energy over v squared. Substituting the numbers, 2 times 32,000 over v squared, it's 8 squared. By using calculator, it's 2 times 32,000 over 8 square. The answer will be 1,000. Just to find a mass, it's a 1,000. So mass here, it's 1,000 kilogram. Use it to get the kinetic energy in the second case. Kinetic energy in the second case, it's a half mv squared. Half times 1000 times 16 squared. Let's calculate. Half times 1000 times 16 squared. The answer will be 128,000. The same answer. Many ways to get the final answer correct, but you can choose any method you like. Question 10. The sun is not primary source of energy for which resource? For oil, tidal, wind, wave, surely it's tidal because it depends on the moon movement. Question 11. An experiment is done to compare the rate of conduction of thermal energy in a metal and plastic spoons. Here is ice cube placed on one end and heated gently. For metal spoon or plastic spoon, surely metal will conduct and ice here will melt. Plastic energy cannot be transferred. So metal is a good conductor here, yeah, A or C, because ice cube would melt more quickly on the metal spoon, on the metal spoon more quick. So correct option is A. Easy. Question 12. For a student, determine the efficiency of 4 different electrical devices. The teacher knows that one student has made mistake in calculation, which value of efficiency is not correct. 12, 36, 78, 102%. Wow. Why 102? Surely it's not. It's not Pro Max. So cannot exceed 100%. So let's continue. A sample of gas is sealed inside a container of a fixed volume. The temperature of the gas increased. Temperature increased. Which statement explains why the pressure of the gas increases? As temperature increases, pressure also will increase. The gas particles collide with the walls of the container more frequently? Surely, yeah, because pressure of gas inside container, it's by the collision of the molecules on the wall. So the correct option is A. For other options, is the mass increases? Surely no. Number of gas particles increases? Surely no. The time between collision increases? Also no. Correct option is A. Question 14. A student does an experiment to determine the specific heat capacity of metal block. She records the following measurement. Here is the energy, initial temperature, final temperature, and mass. What is the specific heat capacity? The specific heat capacity, C, equal to amount of energy over mass, delta T. Change in temperature. What is the change in temperature from initial 20 to 45? It's 45 minus 20, it's a 25 degree. Easy to find C? Yeah. C will be 12 kilojoule, so 12 kilo times 10 power 3. Mass, it's 600 gram. Do I use gram here? Surely no. So it's 0.6 kilogram. The change of temperature is 25 using calculator. Here, 12 times 10 power 3, 12,000 over 0.6 times 25. The correct option is 800. 800, option D. Easy calculation. Question 15. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into a warm surrounding. Okay, which statement about the metal block is correct in the morning? In the morning, when it's get into warm, the internal energy increases. Yeah, heat is the internal energy. While warming, increasing temperature, heat energy also increased. So A is a correct option. If you check the other options, also will not work. Question 16. A fixed mass of gas is contained within a sealed cell at a pressure of 100 kilopascal. This is the pressure. Okay. The plunger is slowly moved until the pressure 80 kilopascal. This is the pressure in the second case, so P1 and P2. The final volume of the gas is 50. So as 50, so V2, the temperature of the gas doesn't change. What is the volume of the gas before the plunger is moved? Here, as the relation between pressure and volume at a constant temperature, so V1 equal to V2. We ask here for V1, so V1, it's V2 over V1. This V1 will go denominator here. Substituting numbers, V1 is V2, 80 kilopascal. Kilo and kilo no need to change, 80 kilo. And volume is 50 centimeter. And here it's 100 kilopascal. For that, we'll do basic mathematics here. Kilo and kilo will remove, 0 cancel 0, 0 also cancel 0. The only remaining down is 1 in denominator. So it's 8 times 5 equal 40. The remaining is 5 and 80. If you want to use calculator here, let's see. 80 kilo, 1000 times 50. And in denominator, it's 100 kilo times 1000. The answer will be also 40 centimeter cube. This is the correct option, B. Question 17. The diagram shows the more energetic water molecules escaping from the surface of the liquid of the water. Molecules of water here escape. What's this process called? As escaping, it's evaporation process. Evaporation process. Easy. Question 18. Out object emits thermal radiation, which Rho described to changes that both reduce the rate of emission of radiation. How to reduce the rate of emission? See, for surface area, it must be increased? Surely no, it must be reduced. For surface temperature, as it's increased or reduced, also reduced. Correct option is D. Some basics. Question 19. The frequency of the wave is doubled. Frequency is doubled. And the speed of the wave doesn't change. What happens to wavelengths? From relation speed equal lambda f, speed is a wavelength and frequency. The relation between them is inverse relation between frequency and wavelengths. As frequency is doubled, so lambda will be halved lambda. So it halves. Easy. You solve problems like that. Question 20. Which statement about ultrasound is correct? Ultrasound, which is not audible, it's a higher than audible sound. So higher frequency mean than audible sound, yeah, and it's longitudinal wave. It's a sound, yeah, longitudinal wave. Option A is correct. Also easy. Question 21. Which statement about the image produced by a plane mirror is not correct? By a plane mirror, here, image will be formed behind the mirror, same distance. And this image, we know that it's a virtual upright. The image is real? Yeah, it's not correct. Image is not real, it's a virtual image. Question 22. a ray of light is incident on the boundary between air and water. Under which condition is the ray of light totally internally reflected? Here we have air and water. Which one makes the light beam totally internally reflected? I know that total internal reflection happens from denser to less dense. So which one is denser? It's a water. So incident light beam on the water. What happens here? Here, if you have a critical angle, the light beam will reflect on the boundary surface. If it's more, light beam will do total internal reflection. This is the process for critical angle. Expanding here, again, I know that total internal reflection happened if you have here water and here is air. Light beam falls. If it's at critical angle, the light beam will refract on a boundary surface. If it's this ray moves a little with the angle more than critical angle, the light beam will do total internal reflection. So this is the process again. Oh, this is how it works. For that, the ray initially in the air, surely no, initially in water. So let's continue for C. Is incident on the water-air boundary at an angle, any angle of incidence? Surely no. It must be condition greater than critical angle, option D. Very good question. Question 23. A converging lens is used to make an image on a screen. Here, converging lens, candle, and screen here. Which type of image is formed on a screen? The image will form on a screen as it's a converging lens. Let's see how it can be drawn. See here, I drew the two lines out, X is here. So the image here will be upside down, inverted, and as it from refraction of actual rays, so it's real and inverted, option A. Question 24. A negatively charged rod is brought near a metal sphere. Charged rod, metal sphere. A positive charge developed on the surface of the sphere closest to the negatively charged rod. Why is this? Why on a sphere the positively charged exists here more and electrons will move away? Because electrons in a sphere are attracted to the negatively charged rod. He told you here it's a negatively charged rod. So the negative charges here will repel. Electrons will move. But is there any chance for positive to move? Positive charge is described as protons. Protons don't move. So only electrons will move. Attracted or repelled? Repelled. So repelled by the negative charged rod. Positive charges in a sphere attracted or repelled? Surely no. Positive charges don't move at all. Question 25. The electromotive force, EMF, of cell is defined in terms of which quantities? EMF, V equal W over Q. We define it as the total work done to move one charge all over the circuit. This is the electromotive force. So, is it energy transferred? Yeah. By the cell moving charge around the circuit? Surely, yeah. Moving voltage, voltage is a concept. Power transferred, power also not transferred. Question 26. A resistor of resistance R is connected to a battery of electromotive force EMF V. There is a current I in the resistor. Power P is dissipated by the resistor. In time T, energy transferred. Which expression is correct? We know that, we solved it before. E equal B times T from radiation power equal energy over time, and electrical power, it's VIT. So VIT equal to energy. It's IVT, option A is correct. Question 27. Copper wire of length 80 centimeter. This is the length. And the cross-sectional area of 0.20 millimeter square. So here it's cross-sectional area A. Has a resistor R. Which length of the copper wire? We ask here for the length, second length. So it's A1. Which cross-sectional area is 40. So A1 and A2. Has the same resistance R. Relation between two variables, I'll use ratio method. Ratio method says, remember the rule first, R equal rho L over A. So for same R, it will be L1 over A1 equal to L2 over A2. Substituting numbers, it's L1, it's 80. A1, it's 0.20 equal to L2, this is what he asked about, L2 over A2, it's 0.40. By using calculation, cross multiplication here, L2 will be 80 times 0.40 over 0.20. Let's use calculator. It's 80 times 0.40 over 0.80. The correct option is 40. So 40 now. 40 centimeter. Here, 40 centimeter, option C, correct. I think it's easy now to use this ratio method. Question 28. For identical resistors are connected to a battery as shown here. Each resistor has a value 120. 120 ohms for R1, R2, R3, R4. Then resistor R is removed. Which effect does removing the resistor have the effective resistance of the circuit? When you cancel R4, what's going to happen? In a question like that, I prefer to calculate to make it easy for me. What is the calculate resistance here? The combined R. First, you have R2, R3, R4 in parallel. So R in parallel equal to, as they are equal, so one of them 120 over the number, which are 3. So total R is 40 for this parallel, 40 ohms. And R1 with this R in series, I'm gonna add them. 40 plus 120 will be 160. This is by using R4. And now, if you remove this R, خلاص, what's happening? Could we find RC? Yeah. RC here, first I'll get R in parallel, will be, as they are equal, one of them over amount of them 1, 2, or over 2, 120 over 2, gonna be 60 ohms. RC total will be this 60 now, and this is 120, summation of them, 180 ohms. So before removing is 160, after removing is 180, so resistance increases. The effective resistance doesn't change, only knob decreased, knob increases here. Yeah, correct option is C. Very, very good question. Now, question 29. The resistors in the circuit shown in the are identical. Reading of voltmeter is 1.5 of V2. Here is the V2, 1.5. The reading of ammeter is 0.50 E2, 0.50. And the reading of A3, it's 0.25. For that, he asked here, what is the reading of A1 and V1? How to get the reading for A1 and V1? V1, it's a EMF. And as this three R, or 1, or 2, or 3, are equal, for that this voltage is 1.5, so also here it's 1.5. Same current, same resistance, so voltage will be the same. For that, the lower branch voltage is 3 volts. And in parallel, each branch, this branch and this branch also, they must be equal to EMF. For that, the EMF for V1, it's 3. Which one? Maybe option B or D. For the current here, for the current, he told you here 0.25, A2 it's 0.50, here current branched, it's branched here, so summation of them 0.50 plus 0.25, 0.75 ampere as a result, which is option D. D is the correct option. Very, very good question. Question 30. A wire is moved in the region between the poles of the magnet. Here is a wire carrying current moving from north to south pole. A current is induced in a wire. In which direction is the wire moved? Here, what the rule you're gonna use? It's Fleming right hand rule. Fleming right hand rule said that your middle finger will direct to the direction of the induced current. The second finger direct to from north to south here, and the motion, it will be your thumb. Let me attach image to make you understand this carefully. This is the right hand rule. Here, this is the direction of the current. Direction of the field is this, what you have to reverse it, your hand to match. You're gonna find your thumb direct into the paper. So it will be perpendicular out or into, no, into the paper. So right option C. If you're still confused, try to contact with me. I'll try to explain as much as I can. Question 31. A fixed resistor is connected to a secondary coil of a step-down transformer. The transformer is 100% efficient. The variable resistor is adjusted so that the current in the fixed resistor decreases by 0.25. Here, this variable resistor adjusted to make the current IS in the secondary coil decrease by 0.25. What is the change of the current in the primary circuit? I know that for step-down transformer, IS must be more than IP in primary more than current in the secondary coil. For that, if the secondary coil decreased by quarter, so IB must be decreased as quarter 0.25 or decreased by less. Why? Because it's normally the current here, primary current, is more than secondary current. So correct option is B. Question 32. An electric device changes the voltage of an electric supply from 240 to 20 volts. 240 volts to 20 volts. What is the device changing the voltage? It's a transformer, surely. Easy. Question 33. An AC generator is set up so that the coil of the wire is perpendicular to the magnetic field. The coil of the wire is rotated slowly to produce an alternating electromotive force a graph of the induced EMF against time is plotted as the coil rotates. Okay. Which section of the graph represent rotation of 3/4? 3/4 of the term. So let's check from O. Here all starts from O. Okay. So O to P, it's a quarter. P to Q, second quarter. Q to R, third quarter. So from O to R. Option C. Question 34. Iranian nucleus U92 and 238. U92 and 238. Decays to form thorium by emitting an alpha particle. Forming thorium plus alpha particles described as He24. Getting the difference, it's 90 and 234. Great. Now, thorium decays to protactinium by emitting a beta particles. Beta particles is E -1 and 0 plus protactinium, it's a Ba. What's the result here? 90 and 234 by -1 here, so this must be 91. And mass number, it's a 234. Because mass number for beta, there is no any change for a mass number, but number of protons will increase. For that, 91 and 234, option C. Easy. It's not easy, but you need to be careful with that. Question 35. Which row shows what happens when the nucleus decays by emitting a beta particles? By a beta particles, we just said now, it makes a proton increase and mass number doesn't change. So the particles emitted, it's an electron, not proton. It changes in the nucleus. A neutron, it changes into proton and electron. Yeah. Why? Because proton cannot change into neutron and proton and electron. So correct option is A. Question 36. Which precaution doesn't always reduce scientist exposure when working with the source of ionizing radiation? For most precaution doesn't work. Let's see. Ensuring the scientist only work with the source of radiation that have longer half cycles. Actually, we can detect that because some it's like a few minutes for a half cycle, for a half life cycle. For that, this may not work properly. So I'll just tick here to see other options. For B, increasing the distance. Increasing the distance, it will work, by the way. So it will work. Limiting the time which scientists handle the source of radiation, yeah, it will work. Placing a lead shield between the scientists, yeah, it will work. So the least work one here, it's A. Question 37. A detector is placed near a radioactive isotope and records a count rate of 700 counts per minute. So radioactive isotope radiates 7 counts. The half-life of isotope is 8 minutes. The average background count rate is 60. Okay. What is the count rate measured by the detector after 16 minutes? See, for 16 minutes, how many half-life cycles? It's 16 over 8 to half-life cycles. Okay, this is the beginning. Then, what we gonna do with this 60? Habibi, we told you before, the 60 doesn't change. But to calculate the half-life cycle, I have to subtract it from 700. So the actual amount will do the half-life that will radiate, it's 700 minus 60, it's 640 counts per minute. Clear? This will radiate So by counting, it's 640 over 2 half-life cycle. First half-life cycle, it's 320. And then the 32 over 2, it's 160 counts per minute. So in beginning, I'll go for B. But as you subtract this 60 from beginning, you have to add it again because it's a fixed value. This fixed value doesn't change. You subtract it from beginning to find 640, which is used actual amount to radiate, to be radiated. So this one is the 160. It must add 60 again. So it's a 220. The right option is D. Easy and simple technique, but you need to focus on solving question like that. Question 38. The nucleus of an isotope of nitrogen N, here is N, absorbs neutrons. It then decays into isotopes of carbon, one isotope of carbon, 614, and emits X. What this X is? See, the left-hand side must be equal to right-hand side. 0 for proton number is the atomic number here. 0 and 7, it must be 7 and 6, so this X must be 1. For mass number, it's 1, 14, and 14, so the difference here is this one, so X11. X11 described by protons shall be. Easy. Question 39. The graph shows how the strength of the Earth's gravitational field varies as the distance from the Earth's surface increases. There is a strength G and distance D. We know that it's an inverse relation. Okay, inverse relation makes, which will describe the effect that has on the mass and on the weight. For mass, we know that mass doesn't change, so A or B cannot be, it's unchanged. For the weight, as a distance, as it moves farther away from the Earth's surface, distance increases, so weight will decrease. Inverse relation, distance increased, G will decrease, makes a weight, mg, decreases also. Easy. Question 40. A student plot a graph of a speed of different galaxies moving away from Earth against their distance from the Earth. Here, this graph for speed and distance. Using a best straight line shown on the graph, what is the value of the Hubble constant H naught? Hubble constant, it's speed over distance. Speed over distance. This is the average one. Which point you're gonna use? I can see here, any point can intersect here. Easy to be calculated. Here you're gonna find 20 million. Okay, and distance is 1, but don't forget it's 1. Here is 10 power 25. So it's 1 times 10 power 25. It's a timed here. For that, let's calculate. Here is 20 million, 1, 2, 3, 1, 2, 3, over 1 times 10 power 25. The answer will be 2 times 10 power negative 18. 2 times 10 power negative 18. As this is speed, this is distance, so it must be second power negative 1. The right option is A. And by this, we are done now with this paper. One of hardest and very, very good paper to be solved. See you next time with IG Nova, with more past paper for IGs and A level. Assalamu alaikum wa rahmatullahi wa barakatuh.